Okay, so that was the primitive economy. But what happens as um, labor productivity increases even further? So in the primitive economy, we're just scratching the surface. Labor productivity increases, we extract more and more. At some point, we're going to stop scratching the surface and actually start going deeper, aren't we? And that is going to push the price up. And that will slow down the rate of increase in extraction. So maybe there's some intermediate phase when the rate of increase of the price is just enough to track the growth rate and to hold the extraction rate constant. Okay, so that would be an intermediate phase with an increasing resource price and a constant extraction rate. And that would be like the land, sunshine, wind case from earlier, right? And well, we're going to have a look at that now. So we're going to assume that such a phase exists. Yeah, it's a balanced growth path on which x, the extraction rate, is constant. And then we know, actually, from the Cobb-Douglas, that that means that the price has to grow at the growth rate. Characterize that path. So what happens on that path? So we're told by assumption that x dot over x is 0 on that path. Okay, x is constant. So that tells us that AD dot over AD is also constant. Okay, but what is the level of AD dot over AD? Well, if we go here, we can see that if x is constant, we're in balanced growth, so Lx must be constant. We can't be shifting labor from one sector to another. That wouldn't be balanced. So if this is constant and x is constant, then these two, Ax and Ad, they have to be growing at equal rates. Okay. If something's growing at 2% a year, the other one must also grow at 2% a year. Then the ratio will be constant. But Ax is growing at G, so AD must also grow at G. That's this one. If AD is growing at G, then x over phi equals G. X is phi times G. So that tells us the rate of extraction on this balanced growth path. And if x is constant, we can very quickly look here and do first order conditions and so on and show that y dot over y is 1 minus alpha. Theta ay is 1 minus alpha times the growth in ay. Ly is constant, x is constant. We also know from the profit maximization that the resource takes a factor share alpha. That's the Cobb-Douglas. Labor takes factor share 1 minus alpha. Resource takes a factor share alpha. We've seen these results several times before, but I've not explained it before in terms of factor shares. So the price of the resource times the quantity is alpha y. So Wx dot over Wx equals y dot over y. So the price tracks the growth rate. So that's the intermediate phase. And that's like land or wind or so on. In the simpler cases we looked at before, constant flow of the input, price tracking the growth rate. What's the relevance of this? Well, we see this for land, we don't see it for resources. But I'll argue, maybe later we'll see, or we can talk about it in class, that ultimately land is going to become incredibly important. Like if you think For energy, we need land to harvest sunshine, we need land to harvest the wind. Conflicts over land use are going to get more and more important. Even for resource extraction, this conflicts, if you think of the conflicts in northern Sweden with the Sami, it's a lot of it is about like you're taking our land to build your mines or to create these mines. So the question is going to be more and more like, what do we use our land for? The price of land is going to grow at the overall growth rate of the economy, and we're going to have this resource allocation problem in society. What do we use the land for? And of course, there's a lot of potential uses. Okay, so that's the intermediate phase, and I'm going to stop this video.